Stop right there. You have opened your Unreal Engine scene. It's beautiful, detailed, alive, cinematic. But the moment you press play or even orbit the camera, frames collapse, the GPU screams, and everything turns into a slideshow. We have all been here. This series is not about hacks, not about guesses. It's about data, diagnostics, and optimization workflows used in real production environments. My name is Hami Jalili, Principal Technical Artist and Animator at Firesprite Sony Studio, and in this first episode, we profile the city, we measure before we modify, because we cannot improve what we cannot see. This episode is slow, intentional. We are not rushing. We are learning the system deeply. By the end of this lesson, you will know how to baseline performance, how to read CPU versus GPU time, how to expose draw calls properly, how to detect bottlenecks visually, how to record performance changes over time, how to profile while moving, not standing still, how to extract the truths from Unreal. This is X-ray scan of your open world. Before we optimize anything, we listen to the engine. Okay, let's get started fresh by creating a new project. I'm going to create a new project by clicking on the new project button, select game template and third person one. Let's call that Beach City because we are going to use the Beach City modular pack from the Fab store. When the project created, we will go to Unreal and library and then we are going to download the assets. We will select our newly created project and we will add that to the project. When the download finished, we will be able to open the project. Okay, the scene just loaded and we are going to run that for the first time. To see the frame rate on the screen, we need to hit the tilde key, and if we type stat FPS like this, on top right corner of the screen we could be able to see the frame rate, which is roughly 41. There are some more useful console commands to get started with, like stat unit. We have a stat unit and also we have unit graph, which also showing a graph at the bottom left corner of the screen as well. And at the top right corner of the screen, we also could be able to see the frame time, game time, draw time, and the RHIT time. Also the GPU time. Currently you could see the frame time is 25 milliseconds and most of that is consumed by GPU time, which is roughly 23 milliseconds. There are some more useful console commands like stat GPU, which will give us some more information about how that 24 or 23 milliseconds spent. At the first row of that, you could see the QoE total, which is 23 milliseconds, and at the bottom of that, you could see the breakdown of that. The first row right under the total is the deferred lighting, so you could see most of the rendering time is spent for the lighting, and at the third line you could see the light itself as well, and then shadow and post-processing. So this will give us a very good idea about how the budget are spending, and also that would be very good to take a look at the CPU as well. Another good useful command that we could use is stat gain. And this one will give us some information about how the CPU is working. So at the first row of that, you could see the tick time is roughly 2.8 milliseconds, which is not too bad for a big city like this. So the bottleneck is not CPU and most of the delays are coming from the GPU side. That would be also good to take a look at some other console commands. First, to clear the screen, if you hit the up key, you could see the last console command that you used, and if you press that again, that will be cleared from the screen. Let's also get rid of the stat GPU, and another console command that would be very useful here is stat RHI. Okay, at the RHI graph, the important things that we need to take care is the throw primitive count, which right now is 6,600, which we need to decrease that number as much as we can. And other useful tool that we could take a look right now is Unreal Insight. So as long as the game is running, if we hit this button and walk through the scene, that will collect the data for the Unreal Insight. And if we stop the game or pause this button, like pressing the red rectangle there, then we could be able to read those data inside the Unreal Insight. We will get the list of all the recorded information there, and if we double click on that in a new window, it will show us the detail of that recorded data. Just as we can see in this recorded data, there are some spikes, and if we click on those spikes, that will show us that frame. So we could be able to zoom on that frame, and as you could see, that spike frame is selected, which is 85 millisecond, which is too much, and we could be able to read the data and find out what's going on there. So basically, the most time consuming here is the game thread, wait for a task. So this spike is caused by the CPU, but we also could be able to take a look at some other frames like this spike, and this one is waiting for the scene render. So there are some spikes caused by both CPU and GPU that we need to address that later. One good thing about the profiling that we did, that's not just a still frame. We moved through the scene and we recorded that. So roughly we recorded for 6 seconds, and these are the information that we're getting for recording that 6 seconds. Okay, let's get back to the scene and check something else. So I just wanted to check the instancing. First, let's get rid of the RHI stat. And also we can turn off the stat unit. Okay, let's get back to the scene and check something else. The first thing that I wanted to check is world partition setup. Just as you can see, this scene is not set up for world partition, and world partition is disabled for this map. The other thing that we need to check is the instance geometry. To make sure the scene has instance geometry properly, we could take a look at the Nanite visualization and take a look at the primitives. Okay, let's check some of this building. Just as you can see, each one of these panels use one instance mesh, which is not the optimized way to do this kind of stuff, especially for a big city like this. So yeah, these are something that we need to address at the next chapters. So in this episode, we captured the truth, we document evidence, we know where we stand. Next, we configure the engine, we stabilize the render, we lay the foundation for the scalable open world pipeline. Move with me to part 2, project setting, slow, controlled, methodical. This is just the beginning. So see you in the next chapter. Thanks for watching.